Hi there, this short video today is over simplifying radicals. A radical expression is an expression that contains a radical, and when we simplify these we want to make sure it checks three boxes. The radicand has no perfect square factors other than 1, the radicand contains no fractions, and the radicals appear in the denominator of a fraction. So let's kind of discuss some examples and non-examples. If you look, 3 square root 5 is simplified. The reason is the square root 5, there is no perfect square other than 1 that can multiply to get 5. On the other end though, if you look at 3 square root 12, we know 12, some factors of 12, we could break that down into the square root of 4 times the square root of 3. The square root of 4 is a perfect square. So this is not simplified as much as it could be. 9 square root x, simplified. The square root of x over 2, this is not simplified. There is a fraction. The entire fraction is under a radical, so that is not simplified. Square root 2 over 4, this is simplified. There's a radical, but it's in the numerator. On the other side, 5 square root 7, this is not simplified. The radical is in the denominator, so we would have to use what is called rationalize the denominator, and we will get to that then here in a few slides. So what do we do when taking the square root of a number that is not a perfect square? So remember, your perfect square numbers are 4, 9, 16, 100. They're all perfect squares because a number times itself gives us that number. So what we do is, for example, if we were given the square root of 48, we want to find the two factors that multiply to give us 48, and we want the factors to be the largest perfect square. So 48 can be broken down into the square root of 16 times the square root of 3. Square root of 16, that can be reduced or simplified to 4. Square root 3, there is no perfect square that multiplies to give us 3, so we could leave the answer as 4 square root 3. Let's look at some other examples. Square root of 72. So again, we're looking for the largest perfect square that is a factor of 72. So for instance, if I wanted to list some factors, I could say 2 times 36, 3 times, 24, 4 times 18, I know there's more, 6 times, I don't know, let's see, 6 times 12, and 8 times 9. So remember, we're looking for the largest perfect square. Well, out of all of these numbers, my largest perfect square is 36, so I'm going to use 2 and 36 as my factors of 72 to help me simplify. So the square root of 36 times the square root of 2. That's the same thing as saying square root of 72. It's just written a different way. Now let's go ahead and simplify. The square root of 36, that gives me 6. Square root of 2 can't be simplified. There's no perfect square other than 1 to give us 2. So my final answer here would be 6 square root 2. All right, number 2. Negative m times the square root of 80 m to the 9th. So we have a few things going on here. First off, we have a negative m on the outside of our radical. So that just means kind of like when you do parentheses, if there's something on the outside of the parentheses and you simplify, you have to make sure to multiply that by it. So we're going to first, let's reduce the 80, and then we'll talk about the m to the 9th. So square root 80. Again, what are two factors? And we're looking for the greatest perfect square. So again, let's break down our factors. If this helps you, go for it. So 2 times 40. What else here? 4 and 20. So there's a perfect square. We just don't know if it's our largest perfect square yet. Let's see, 5 and 16. All right, 8 and 10. Sorry, guys. And that's all our factors. So basically, out of all of these factors, what is our largest perfect square? Well, our largest perfect square would be 16. So we want the factors of 5 and 16. So I'm going to rewrite this as the square root, or negative m square root of 16 times the square root of 5 times m, I'm going to do square root of m to the 9th. All right, well, my square root is 16. That can be reduced to 4. So on the outside then, I have this negative m times 4 times the square root of 5 times my square root of m to the 9th. And eventually you guys will get the hang of this, so you won't have to write out every step, but for right now I'm going to write out every step. So this can then be negative 4m times the square root of 5. Now we're going to go ahead and we are going to take the square root of my exponent. So basically that is saying we have 9 m's. Well, we know the square root of 9 is 3, so this turns into times m to the 3rd. This is going to be on the outside, so I need to make sure so let me change colors here. So I need to multiply negative 4m times m to the 3rd. They're no longer under radicands. So I can go ahead and I'm going to multiply those. So my final answer here would be negative 4m to the 4th square root 5. And that is simplified as far as it goes. Remember, you add exponents when multiplying. So that's how I got 4 there. All right, last example for this part, square root 2a times the square root of 9a to the 3rd. Let's go ahead and let's multiply to get one radical, and then we'll break it up. So I'm going to multiply my coefficients. So I'm going to get square root of 18, and then a times a to the 3rd, a to the 4th. So remember, when you multiply radicals, you can put it under one radicand. It's the same thing. I'm just writing it in a different form. So now let's go ahead and break up 18. So my factors of 18, 2 and 9, 3 and 6. Well, we want the one with the largest perfect square. 9's my perfect square. So this breaks down into the square root of 9 times the square root of 2 times the square root of a to the 4th. Well, the square root of 9 we know is 3. Square root of 2, it's broken down as far as it can go. And then remember, a to the 4th, or basically what's that square root of 4? It gives us a squared. So be careful because that's not under the radical. So I'm going to move it out in front. Be really, really careful here because if I left it where it was, it could be mistaken for being under that square root. It's not. So make sure you move it out in front. So my final answer here would be 3a squared times the square root of 2. All right, now let's look at dividing radicals. So if I have the square root of a over b, I can rewrite this to be a radical on top divided by a radical of bottom. So basically a radical in my numerator and then a radical in my denominator. So for instance, square root of 144 over 9. I can rewrite this to be the square root of 144 all over the square root of 9. Now this helps me though because the square root of 144 simplifies to be 12. The square root of 9 simplifies to be 3. 4 divided by 3, or 12 divided by 3 is 4. I just gave it away. Here's the thing. You also could have seen 144 divided by 9 is 16. So we could have simplified it right away. And then the square root of 16 is 4. Either way works just fine. So let's look at the square root of 36a all over the square root of 4a to the 3rd. Same thing. I could rewrite this as 1. Now here's the thing. You're probably thinking, why am I going to rewrite it as 1? We just rewrote it as 2. Here's why. Let's go ahead and let's reduce it first. So let's see. 36 divided by 4 is 9. So this turns into the square root of 9 all over a squared. Again, remember, how did I get a squared? My rule is I subtract my exponents. I have 1 on top, 3 on the bottom, so I'm left with 2 on the bottom. All under one radical. Now I'm going to break it up. So I'm going to break it up to square root 9 all over the square root of a squared. Well, square root 9, that simplifies to be 3 on top. Square root and a squared, remember they're opposites, they cancel out. So my final answer is 3 all over a. I got rid of my radicals. Now what happens though if we end up with a radical in the denominator? This is what we call rationalizing the denominator. In order to rationalize the denominator, we're going to multiply the numerator and the denominator by the radical that is in the denominator. It's a handful, but we got this. Here we go. 2 square root 3. I can't simplify it. It can't be reduced. Nothing divides. Square root 3 is simplified as far as it goes. So I know I have to rationalize because remember, back to my rules, it has to hit my check marks. There can't be that radical in the square root. So I'm going to multiply the top and the bottom, my numerator and my denominator, by my square root 3. Here's why. Look what happens. When I multiply, so I have 2 times square root 3 on top. On the bottom, I'm left with square root 3 times square root 3. Square root 3 times square root 3 becomes square root 9. What do we know about the square root 9? That's a perfect square. So this simplifies to be 2 square root 3 all over 3. And look, I no longer have a fraction or a radical in my denominator. So I'm all set. It is simplified as far as it can go. There's nothing that can be reduced. It hits all my check marks. All right, square root 5 all over square root 18m. Okay, again, let's go ahead and let's rationalize. The 5 and the 18m, they're not going to reduce in order to get rid of that square root in the denominator. So we're going to go ahead and let's multiply the top and the denominator by square root of 18m. So my numerator, let's see, 5 times 18 gives us 90. So on top I'm left with 90m all under my radical, so make sure it's long enough there. All over, well, 18m times 18m, well, 18 times 18 is 324. The square root of 324 is 18. So it's 18m is what I'm going to be left with. Now, though, let's go ahead and square root of 90m. Let's see if we can reduce that any. Let's see if we can simplify it anymore. So let's see, 90, my factors of 19, 2 and 45. So let's see, 2 and 45, 3 and 30, 5 and 18, 6 and 15, and then 9 and 10. So we're looking for our largest square root. I think the largest square root is 9. So this simplifies into square root 9, square root 10. Square root 9 simplifies to be 3. So my final answer here, I'm sorry I kind of going everywhere, is in my numerator, I'm going to have 3 and then square root 10m. Don't forget that m that we had under there, all over 18m. Lastly, the 3 and the 18 can be reduced because they're not under the square root. So the 10 and the m we can't reduce with because they're under the square root. The 3 and 18, 3 goes into 18 6 times. So my final answer here, sorry guys, is square root 10m all under the square root all over 6m. There you go. If you have any questions or need anything, please don't hesitate to ask your teacher.